So I know the suspense must be building in you because you know that I've only talked about the y-coordinate of the person, right? The person's right here, and what is their y-coordinate? That's what we did. We figured out it was just sine of theta, right? But what about their x-coordinate, right? It's like, don't leave us hanging with x-coordinates. So let's try to see what their x-coordinate looks like. Well, if we're right at 0 degrees, or 0 radians, what is the x-coordinate? Well, this is a unit circle. That's a 1. So right at 0 degrees, I am at 1. Okay? Now, if we go up to 30 degrees, there's 30. This is still a 1, but what is my x-coordinate now? Well, just remember your trig here. This is the adjacent side, and I know the hypotenuse, so ka, toa, it's the cosine, right? So if I need the x-coordinate here, it'll just be the cosine of 30 degrees equals my, if I call this x here, equals x over my hypotenuse of 1. But check it out. You remember this from last time? Guess what anything divided by 1 is? Just itself. So we get this. So it looks to me like my x-coordinate is just the cosine of 30. Go ahead, plug it into your calculator, tell me what you get. Just kidding, you can't talk to me right now. But this 30 degrees is just going to be 0.866, which you might remember as the square root of 3 over 2. So I'm just going to use this root 3 over 2, okay? Square root of 3 over 2. Great. Some of you people that are knowing what a 45-degree angle is, you might already know what this is. But let's say you don't, okay? Because you can always figure it out if you don't get it, or if you don't see the pattern here developing. So if I put in that 45-degree angle, our person has now moved up to 45 degrees. And I'm wondering what my x-coordinate is now. Well, just build the relationship here. We're still going to be using cosine, but now we'll do the cosine of 45, and we'll end up with the cosine of 45. But you know something? Can you tell you have an isosceles right triangle here? In other words, at 45 degrees, if this is 90, then these two sides are the same. So if we had 1 over square root of 2 for my y-coordinate, we're going to have the same thing for the x-coordinate. And now some of you might be seeing it, so I'm just going to shorten this video up. Like, yeah, we need to get it for 60. Yeah, oh, 90 is easy. Wait a second. We can get 90. Because if I go all the way up and my person's right up here, guess what my x-coordinate has shrunk to? Goose egg, right? Nothing. So the only one left here is what is my x-coordinate at 60? But if you haven't seen it yet, I'm just going to alert you to a pattern. I hate to draw on this, but I'm going to do it anyway. Actually, here, let me do this. If you take these values and then you flip them, bam, can you see they map perfectly? Like this 1 ends up being up here. This root 3 over 2 ends up being right here. The 1/2 meets in the middle. Guess what has to happen for 60? We're going to be at 1/2. Okay, and then we got the 0. Well, we have been talking as though we're looking at the x-coordinate, and we are, but also can you tell what function this is? It's not sine theta anymore. What function have we been finding again and again and again? Cosine. So this ends up being cosine of theta. And don't you sort of want to graph it? Am I getting that vibe here from people? Because it would be sort of cool to see, does it look like sine or does it look different? Well, let's check it out. Cosine graph. So let's see, right at 0. Oh, look at it. It's different right off the bat. It starts right at 1, right? 0, 1. 0, oh, jeepers, sorry. 0, 1. So it starts right there. And then we've got 30, and square root 3 over 2 was 0.866. So at 30 degrees, I'm at 0.866. 45, I'm at that same one of 0.707. That was the decimal version of this. So at 45 degrees, I'm like right around here. A little higher probably. And then at 60 degrees, I'm at 1/2. Let me just boost this up a bit here. And then at 60 degrees, I am at 1/2-ish. And then at 90 degrees, I'm at 0. Right, 90 degrees, I'm at 0. And then can you tell what will happen here? Because when I go past my high point here at 90 degrees, and I go over to triangles that are over here, well, guess what the x-coordinate is now? Isn't that negatives? Isn't that in the negative side? And you can probably tell that is not a surprise if you look at where this curve is heading, right? It's going to end up being negatives. And I'll just put in a few dots here. Let's go to 180. Let's figure out what 180 is. Let's figure out what 270 is and 360, okay? So at jeepers creepers, there, okay? I just added those data points. Let's see what our person actually is, the x-coordinate. The x-coordinate at 180, can you tell it'll be -1 there? So that means I'm at -1 at 180, so let's draw that in. Here's -1, -1, 180. What about 270? Let's see. So if I go down to 270, oh, check it out. If I'm down here, guess what my x-coordinate is? 0, right? So that means I've got 270 at 0. And then back at 360, I'll be back at my beginning spot, so at 1. So can you see how this curve is going to look? Oh, come on! I'm trying to do this without quickly here. Okay. Can you see it? So I want you folks to know that sine curve is so ugly. It's usually such a beautiful curve. This will also keep going, right? It'll keep going. So the cosine curve and the sine curve, they sort of map onto each other if you just shift them 90 degrees one way or another, okay? Then they'll map onto each other perfectly. They'll often, when you see them graphed together, they're sort of like chasing each other so that they're, oh, that was not right. Ah, darn it. But they'll end up being almost parallel, almost coinciding with each other, but not quite. Anyway, where does cosine start? If you need to draw the cosine curve, which you will, the cosine curve is just like the sine curve, but it starts at 1. And then it goes down, it goes up, etc., okay? So you need to have the sine curve, cosine and sine curve memorized. Those will come in handy. And you need to have that chart memorized right there so that we're ready to go.